All right, we're going to get going. We're writing equations of ellipses again, and we're finding things like the center and vertex and foci. And then we want to sketch. Right now, this equation isn't in standard form. We can get it into standard form.
How so?
Silver knows how. He's going to tell us. Okay. You want to divide the x's and the y's?
Yeah, I have to like separate them and then separate sides.
We don't have to get them on separate sides for ellipses. That's for parabolas. On ellipses, the x's and y's can stay on the same side. But you might want to group your x's and y's together. So it's probably smart to just say 9x squared plus 36x plus 4y squared minus 8y. Keep the x's and y's together on one side, get the constants out of there. So I'm going to take that 4 and subtract 4 from both sides. Okay. Look at our general ellipse form. It's x minus h squared and y minus k squared. What do we need to do to both of these groups of x squared stuff and y squared stuff? Probably won't help you yet, especially because that's a 9. So I won't divide it. Complete the square. We need something that's a perfect square. X minus h squared and y minus k squared. So we need to look at each one of these as a group that needs to have the square completed. Are there any difficulties to us completing the square right now? Let's just look at the x ones. Yes. Why? Right. How can we fix that? Take a 9 out. Yep. Got x squared plus 4x. How about with the y's?
If you want me to take out 4.
Yeah, I'd take out a 4 as well. When you learned completing the square, you learned it having that leading coefficient be 1. Doesn't work otherwise. If I want to complete the square for x squared plus 4x, what do I need to add? Okay, why? How'd you get that? Just remind us.
4 divided by 2.
Okay, so we did b here, so this is b. b divided by 2 squared. So in our case, our number's 4. So 4 divided by 2 squared is 4. So we need to add 4. I added 4 to this side. How much do I need to add to the other side?
1.
Why 36?
Distribute the 9.
Yeah, so we didn't really add 4. We added 4 in the parentheses. But there's a 9 out here. So it's like we added 9 times 4. We added 36. So when we go to the other side of our equation, we're going to add 36. How about for the y's? We need to complete that square as well. Plus 1? We can, yeah. Even though it's negative, we can complete the square. So we do negative 2, that's our b value. Negative 2 divided by 2 squared. Same thing as always. That's 1. We added 1 to this side. How much do we add to the other side? 4. Yeah, we added 1, but it was in parentheses. So 4 times 1 is 4. Alright, let's start simplifying. I'm going to have 9 times what here? What is this going to simplify to? X plus 2, what? Squared. Yep, this is a perfect square trinomial. That's what we were trying to achieve. What's going to be in the parentheses for the y's? Minus 1 squared. That's It's a minus because we have that minus 2 in the middle. Equals minus 4 plus 36. It's 36. Is this in standard form yet? No. What do we need to do to get it in standard form? Yep, we need a 1 on the right side of our equation. Divide everything by 36. How's this going to simplify? X plus 2 squared over 4. Yeah, because we got 9 divided by 36. It's like 1 over 4. 4 divided by 36. What was that? 9. Yeah, 4 divided by 36, 1 over 9. Yeah, we have perfect squares. We have a 1 on the right side. We have numbers in the basement. We can start writing things like the center, foci, vertices, all that stuff. So can you tell me what the center of this parabola is? We have negative 2 here from our x plus 2 squared. 1 from our y minus 1. It's our center. What's my a value?
3.
3? Okay, how'd you get that?
The bigger one is going to be the major axis, and that's a squared.
Yeah, the bigger one is always a, and this is a squared right here. So a is equal to 3. What's b equal to? That should be a 4. So b is equal to 2. That's for our minor axis. What's our c value? Or a different question. How do we solve for our c value? Pythagorean theorem. Specifically, what's the relationship? Yeah, so we're doing b squared plus c squared is equal to a squared. If you're trying to remember this, remember a is always the biggest value. A is with the major axis. So it has to be a squared. Plug in what you know. You know A is 3, you know B is 2. No? Yes? Yes? Okay. At this point, we have A, B, and C. We have our center. We should really sketch this thing.
I have a question. Would your major axis or your minor axis be your radius? Or is it?
There's
that's only for circles. Oh.
no radius for ellipses, only for circles.
Okay.
Major axis is your largest value. So in this case, is x or y our major axis? Y, yeah, it's our bigger value. So center is at -2, +1. I want to plot one of my vertices. My major axis is y. So how do I plot a vertex? Up 3. We look at our A value. A values with the major vertex. Start at the center. Up 1, 2, 3. We want to plot another one. Where do we go? Down 3, opposite direction. 1, 2, 3. Okay, so this is our major axis. How can we plot some more points for our ellipse? Right 2, left 2. B is associated with our minor axis. So we're going right 2 and left 2. rough look for our ellipse. In your assignment, it will ask you for coordinates. It wants to know things like the coordinates of the center, which we already gave. What are the coordinates of our vertices? So vertices, you said -2, 4, and -2. Yeah, is it -2? Your vertices are associated with your major axis. Those are your vertices. How do we find our focus points? They're C from the center. So C is for our focus points. Which axis are they on? The major axis, yeah. So if I wanted to find my focus points, what would I do? What would their coordinates be? You don't have to simplify the RIP 5. You can leave it as RIP 5. But what would the coordinates be? So it would be -2, right? Because they're on this axis. And then 1 plus RIP 5. Because we're up here at the center. -2, 1, add RIP 5. There's a focus. At the center, down RIP 5. There's a focus. Yeah, so you could do plus or minus, or you could write it as two separate. So we have center, we have vertices, we have focus points. We have a sketch. It's about as much information as you'll ever be asked to provide. 1 out of 4 with this stuff. 3s, 4s, okay. This is, I think, like the only new actual concept for today. It's just a measure of the roundness of an ellipse. It's called the eccentricity. So the eccentricity, E, is defined to be C divided by A. What's C again? C is the distance from the center to the foci. What's A? Yeah, it's the distance from the center to your vertex, yeah, which is on your major axis. So write this down. E can be in between 0 and 1. It's always going to be stuck in between there. And depending what the value is, it's going to tell you something about the ellipse. If you have C values that are really, really close to your A values, what is your E value going to be close to? Your eccentricity. 1. Yeah, if these are really close together, E is going to be close to 1. What would that tell you about the shape of your ellipse? It's pretty what?
It's more close to a circle than it is to a
That would be the other way.
other way.
If E is close to 1, we're going to get something that's really stretched out. Or something that's really, let's say, elliptical. So if your focus points are really close to the edges of your ellipse. Whereas if we had something where, let's say, focus points are way in here. So if your focus points are way in here, what's your E value going to be close to? Why is it it's going to be closer to 0? Because your distance here, your C, is really, really small. So you would end up with an E value close to 0. If your e value is close to 0, what does that tell you about your ellipse? It's round, yeah. Why does e have to be in between 0 and 1? Why can't e be 0?
Because it would be a circle.
Yeah, 0 would be a circle. If c was 0, then you would have no distance in between your focus points and your center. It'd be a circle. Okay, how are we on this? 1 through 4. Eccentricity. Okay, you keep moving. Good friend, application problems. Similar to the parabola stuff, but this time we're dealing with a bridge that doesn't have a parabolic arch. It's a semi-elliptical arch, half of an ellipsis. What was that? So for a bridge that's like an ellipse, it curves in more towards the end. Parabolas are stretched out kind of wide. Ellipses curve in really tight. Okay, we know some things about this bridge. We know it has a span of 160 feet. So from here to here, we're looking at 160 feet. And we know that it has a height of 40 feet. So from the top down, looking at 40 feet. Because the picture has this bridge kind of at an angle, I'm going to maybe do a different drawing. So we have 160 feet that way, 40 feet up. That's pretty close. An ellipse, that looks something like this. Or a semi-ellipse, I should say. Okay, remember with applications problems, what do you have control over? Yeah, where you put, not the vertex, but the...
Where you put it in relation to the origin?
Yeah, the origin. Yeah, where do you put the origin? Where should we put the origin here? In the middle of what?
Where 40 and 60 lines intersect.
Where 40 and the 60 lines intersect. Right here is where you want to put it. Why do you want to put it there?
That would give us more the center of our.
Yeah, remember for ellipses, the important point is the center, not the vertex. So if we can put the center at 0, 0, it means we can use easier equations. X squared and y squared instead of x minus h, y minus h. Make things a little bit easier. Okay, so if we put that intersection point at 0, 0, tell me what this point is at the top of the bridge. 0, 40, yep, x value is 0, we're 40 feet up. Tell me a couple other points. 80, 0. We know that the whole span of this bridge is 160 feet. We just cut that right in half. So we have 80 feet out here. How about this point? What are we trying to find in this problem? Okay, so if we go from the center and we go 40 feet over, we want to find the height of the arch right there. Or for our drawing, it'd be over 40 feet. We want to find that height. In order to do that, we're going to need to know the general look of our equation. What do you know about this equation right now? What's the major axis? X, yeah, we're longer in the x direction. So that's our major axis. So tell me what our A value is. 80? Yeah. So this is our major axis, and it's 80 from the center to the vertex. B is 40. B is associated with our minor axis. From center to the co-vertex, I guess was the goal. So let's write our equation. Just x squared, because we're at the origin. X squared over what? So I heard 80 what? Yeah, 80 squared, which ends up being like 6,400, yeah. Plus y squared over 40 squared, yeah. It's our b value. Equals 1. Now remember, we're interested in this height right here. The height of the bridge, 40 feet from the center. How do we find what that height is? Yeah, just plug in 40. We're just going 40 right from our center, and we want to figure out what that y value is. We're just looking to figure out what that is. So we can just plug it into our equation. So plug that in. X squared over 80 squared plus y squared over 40 squared equals 1. Plug x's 40 in, solve for y. Something for a y value. What was that? 20 root 3. If you do this, or if someone just use your calculator. 34.64. Okay, so your y value 34.64. You go back up to your top. That's your height right here, 34.64. This height. Those are units. Just like parabolas, different.
Can you go back down to like?
Yeah, sure. There?
Yeah.
Okay. All right. You know your assignment. It's day 2. We took off 5 problems. I'm going to pass out the worksheet that we're going to work on in class tomorrow. Don't lose it. And if you could do 5 problems tonight, it would be beneficial to you because then you wouldn't have to worry about it tomorrow night. But other than that, got 10 minutes, 15 minutes.
Let him call you that.
Yep. Oh,
he should respect that you're with somebody, and when he doesn't, he's not gonna respect you in a relationship.
Yeah.